Hello and welcome to notes number 2 for our exponents unit. Today we're going to be working on pages 4 and 5 of your notes packet, and we're going to be looking at applications of exponential notation. So basically we're going to be working on some word problems today. Word problems tend to be challenging. However, we're going to talk about some strategies that you can use to help to make them more accessible and not so intimidating. So why don't we get started? When I approach a word problem, it's important to read it over many times. I don't even try solving a problem until I've read it over a few times. The first time, I just want to get an idea in general about what's going on in the problem. I don't do anything, I don't write anything, I just read it through to get an idea of the kind of information that it has and what kind of questions it might be asking. Then I read it through a second time more carefully to look for more information. So number 1, it says, on Tuesday, Mary found a spot of mold on a loaf of bread in her bread box. The area of the mold was 2 square centimeters. Mary put the bread back in the bread box and left it there. If the mold quadruples in area every 24 hours, how much mold should Mary expect to see when she looks at the bread on the following Friday? Let me read this again to get more detail here. On Tuesday, Mary found a spot of mold. So here I'm going to highlight for myself that on Tuesday, Mary found mold on bread in her bread box. The area of the mold was 2 square centimeters. So this is how much mold we're starting with. Mary put the bread back in the bread box and left it there. If the mold quadruples in area every 24 hours. So the mold quadruples in area. So I'm thinking to myself, quadruples. Well, I see the word quad in it. That means 4. So it gets 4 times bigger every day. How much mold would Mary expect to see when she looks in the bread box on the following Friday? When I have this kind of problem and I see that it's increasing over the course of a few days, I like to keep track of this data. And what I'm going to do is I'm going to keep track of this data in a table. Okay, so let me draw my table. I know I'm keeping track of days because she found the mold on Tuesday, and then she wants to know how much mold will be there on Friday. And then I'm keeping track of area in square centimeters. So we want to be specific about the dimensions. So on Tuesday, she finds 2 square centimeters of mold. Then on Wednesday, we know that it quadruples. So this is quadruples means times 4. So 2 times 4 is 8. So she's going to have 8 square centimeters of mold. On Thursday, quadruples again. So 8 times 4 is 32. And then on Friday, it quadruples again. So for Friday, I'm going to do again times 4. 32 times 4 is going to be 128. Okay? And when I'm done with my problem, or I think I'm done, I always go back to reread the problem to make sure that I've actually answered the question. So it says, how much mold should Mary expect to see when she looks at the bread on the following Friday? And that's what we've calculated. So it's 128 square centimeters. I really like using a table. It comes in handy, and it's a nice way to keep a lot of information organized. Now, you might be asking yourself, why is this on exponents? So I just want to point out, as we're keeping track of what's going on, I'm going to write this out again underneath. On Tuesday, we had 2 square centimeters of mold. On Wednesday, it got 4 times bigger, so this was a 2 times 4. On Thursday, it was 4 times bigger again. So it was whatever we had on Wednesday, which was 2 times 4, and then times 4 again. And then on Friday, it quadruples again. So this, on Friday, it multiplies by 4 again. So we have whatever we had on Thursday, 2 times 4 times 4, and it gets multiplied by 4 again. So another way to write that is 2 times 4 to the third. 2 is the original quantity we started with, and then it got multiplied by 4 for each day that passed, and Friday is 3 days after Tuesday. Thursday was 2 times 4 to the second power. Wednesday is 2 times 4 to the first power. So for every day that passed, it got multiplied by 4. Okay? So it's just a way to represent it with exponents. So let's take a look at question number 2. Question number 2 is very different. Jonathan deposits $350 in a bank account that earns 4% interest, compounded annually, which means yearly, once a year. How much will be in his account at the end of 10 years? So this problem has to do with money in a bank that grows with interest. So when you put money in a bank, the bank pays you for the use of that money. And in this case, that's what the interest is. It's 4% interest. So to calculate how much money you have, there's a formula that's given here that shows us how to calculate the money that we are going to have. So that's the formula right there. Before we get to that formula, however, let me clean this up. Let's reread the problem so we know what's going on. Jonathan deposits $350 in a bank account that earns 4% interest. So $350 is how much he deposits. It's how much he starts with. It earns 4% interest, compounded annually. How much will be in his account at the end of 10 years? This is the formula that's given that's going to help us calculate this. So A represents the amount of money that he will have after all the interest is accumulated. P is called the principal. And what that means is the initial amount of money that was invested. So this is the initial amount that was invested. R represents the rate. That's how much money, that's the percent that the bank is paying you. So it's going to be the rate, but it's going to be a percent as a decimal. Not in the form that it is in now. We have to rewrite it as a decimal. And then finally, the N up here is the number of years, or the amount of time. In this case, it's the number of years that the money is invested. Okay, so let's take a look at what's happening in this particular problem. A, what is A in this here? Well, that we don't know. We want to know how much money is he going to have. That's what we're looking for. P is the principal, the initial amount that is invested. In this case is $350. R is the interest rate. In this case is 4%. But 4% means 4 out of 100. We're going to rewrite this as a decimal, 4 hundredths. So we move the decimal place 2 places to rewrite it. This is 4 hundredths. It's 4%. So we're going to use it as a decimal form. And N is the number of years that it's being invested, which in this case is 10. So it's being invested for 10 years. So this is the data that we're going to enter into our formula. So our formula will be A equals the principal, which is $350. So now we're going to use this data in the formula. A, which is what we're looking for, equals P, which is $350, times 1 plus the rate as a decimal, so 4 hundredths. And all of this is going to be raised to the 10th power because the interest rate will be applied once every year. So for this kind of problem, I'm going to use a calculator. This is not something I'm going to multiply out by hand, but before I do that, I'm going to add the 1 plus the 4 hundredths. So it's going to be 350 times 1.04 raised to the 10th power. So on your calculator, I brought up my calculator here. I'm going to enter the information here. Yours will look a little different than mine, but this is the calculator that I have access to here. So 350 times I'm going to open the parentheses, 1.04, close the parentheses, and I'm going to raise it to the 10th power. So raising to the 10th power on my calculator is this x to the y, but you'll see a little caret symbol, and I'm going to raise 10 equals, and this is the answer. Now remember, we're talking about money here, so I have to remember to round to the nearest penny, which is the hundredths place. So after the 8, which I see in the hundredths place, I see that there's a 5, which will cause that to round up to a 9. So the final answer here will be $518.09. So let me write that in. $518.09. And that's how you use the formula to help you calculate it. Okay, so what I'd like you to do is I'd like you to try the next two problems on your own. I'd like you to press pause on the video, try questions 3 and 4 on your own, and then I'll show you the answers. Okay, I hope you've had a chance to take a look at questions 3 and 4, and then I'm going to show you how I worked this out. So question number 3, your BFF tells you a secret and asks you not to tell anyone. However, the next day you tell 2 other friends the secret. The day after that, each of them tells 2 other friends the secret. If this pattern continues, how many people will know the secret in 1 week's time? Okay? So again, this is a similar one to number 1, where you're starting with a quantity, and then it gets so many times bigger with the passing of time. So your BFF tells you a secret. The next day you tell 2 other friends. Each of those tell 2 other friends. So it gets 2 times bigger each day. So in 1 week's time. So I set up a table, because it's the days that are passing, the number of people. Times 0 means the beginning. So that's what time 0 represents when it starts. So at the beginning, your friend tells you the secret. So she tells 1 friend, you. On the next day, it's you tell 2 friends. So you tell 2 friends. So this is going to be 1 times 2, which is 2. Then on the next day, each of these 2 friends tells 2 friends. So 2 times 2 is 4. On the third day, each of those 2 friends tell 2 friends. Times 2 is 8, and so on. 8 times 2. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. So another way to think about what's happening on the 7th day in terms of exponents is that it started with 1 person knowing, times 2 for the first day, times 2 again, times 2 again for the 3rd day, times 2 again for the 4th day, times 2 again for the 5th day, times 2 for the 6th day, and then times 2 for the 7th day. So you're repeatedly multiplying by 2 7 times. So this is 1, because you're the first person, times 2 to the 7th power to do that. Now remember, go back and reread the problem and see if we've actually answered the question. It says, if this pattern continues, how many people will know the secret in 1 week's time? So if you're really figuring out how many total people, how many people know the secret, it's not just 128 for the 7th day. It's asking you how many people will know the secret. Well, all of these people know the secret. So we're going to have to add up this whole total. So plus the 2 people you told, plus the 4 people on day 2, plus the 8 people on day 3, plus 16, plus 32, plus 64, plus 128. So in all, a total of 255 people know about the secret after a week's time, which is quite a few people. Okay, so let's move on to question number 4. Okay, so for question number 4, Adrian at age 30 invests $3,000 in her retirement account. It will earn 5% interest compounded annually. How much will be in her account when she retires at age 65? So this is another investment question. So we're going to go back and use the same formula from before, where A is the amount of money that she will earn, P is the principal, the amount invested, R is the rate as a decimal, and N is the number of years. So in this case, P is the $3,000 that was initially invested. R is the rate as a decimal. So if it's 5%, that's going to be equal to 0.05 as a decimal. And then N is the number of years, which in this case, if she's retiring at age 65 and she's investing at age 30, so she's going to be investing that money for 35 years. Okay? So this is the data that we're going to be entering into our formula. So I'm going to move this here to the side. And right here, we're going to write in our formula for the data that we have. I've written down our formula and I've substituted the values in. P is the principal for $3,000, 5% interest raised to the 35th power. Now I'm going to add the 1 plus the point. I've added together the 1 plus the 0.05, and now I'm just going to enter this into the calculator to see what we get. So when we put this into the calculator and multiply it out, it comes out to quite a bit of money here. The final amount, and remember if you round to the nearest penny, is $16,548.05. Now I'd like you to pause the video and try the rest of the questions. Try questions 5, 6, 7, and 8 on your own. Try each one, show your work, set up a table. If that's the case, use the formula that was given before. And then once you've tried the 4 problems, you can restart the video to check your answers to make sure that you're on the right track. So go ahead and pause now. Okay, now that you've had a chance to try the last 4 questions, let's go through and correct any mistakes that there might be. So in question number 5, the final answer here is 1,600 bacteria. That's how many there would be after 5 hours. And as you can see, I set up a table to keep track of the data. The tables are very helpful to keep track of data over multiple hours or multiple days. Question number 6. Again, I set up a table to keep track of the number of days and the number of people told, which gets multiplied by 4 every day. Now, the question says how many people would have been told about the movie by Friday? Now, on Friday, 1,024 people were told. However, the question isn't asking that. It says how many people would have been told by Friday, which means you have to add up all the people that were told about the movie. So I added up all the totals for each of the days, and it turns out to be 1,364 people were told in all. So you really have to go back and read the question carefully to make sure that you're answering it. In question number 7, I used the formula again for calculating the amount of money earned with interests. Here's the data that I used to substitute into the equation, and then once I substituted in, rounded it to the nearest penny, it turns out to be $1,187.69. And then finally, number 8, you're looking at folding a piece of paper repeatedly. So each time you fold, you get half of what you had before. So again, I set up a table to keep track of the number of folds and the size of the paper that's left. And each time it's half. So I multiply by half, I multiply by half, I multiply by half, I multiply by half, I multiply by half. So it ended up having 6 folds. If you've had any questions on any of these, please make note of it and bring any questions that you have to class. Thank you.